In this lecture, we'll discuss about basic logic gates. There are three basic logic gates: AND, OR, NOT. Of course, we can include buffer gate also. Okay. Let us see the truth table of these gates. So here I am showing NOT gate and buffer gate truth tables in this table. So these gates contain only one input. So with one input, two input combinations will come. One is 0 and one is 1. I assumed input as A and output as X. So for NOT gate, if the input is 0, output become 1. If the input is 1, output becomes 0. This is nothing but inversion or complementation. NOT. When we are saying 0, it is saying NOT means no means 1. When we are saying 1, no means 0. So that is the meaning of NOT. Okay. So for buffer, same input to output. Suppose for input 0, output will be 0. For input 1, output will be 1. So buffer will produce same output. Okay, but it will act as a temporary storage or impedance matching device. Okay. Now we'll discuss the truth table of AND and OR gates. Generally, these AND and OR gates contain minimum 2 inputs and maximum n inputs. I taken 2 input truth table. So with the 2 inputs, 4 input combinations will come: 0, 0, 0, 1, 1, 0, 1, 1. This is for AND gate, this is for OR gate. So AND gate means in the input combination, if any one input is 0, then output becomes 0. See here, at least 1, 0, at least 1, 0, at least 1, 0. So output became 0. But here both inputs are 1, so output came 1. In OR, if any one input is 1, output become 1. Suppose here both inputs are 0, so output became 0. Here any one input is 1, so output we got 1. Okay na? Output we got 1. Okay. So here we can see the symbols. So here what we say, this AND gate perform multiplication, Boolean multiplication. This Boolean multiplication rules almost same as arithmetic multiplication rules. Both are same. Okay. So this OR gate performing addition, Boolean addition. Okay. But not arithmetic addition. Arithmetic addition different, Boolean addition different. Okay. So now this addition symbol represented by plus, multiplication dot or space. Okay. So this is the buffer gate symbol. It contains one input and one output. This is the symbol. And this is the NOT gate symbol. Just for the buffer, if you keep bubble at the output or input, it will become like a inverter or NOT gate. This bubble indicating inversion. Okay. Buffer indicating same input output, but bubble doing the inversion. Okay. This is the OR gate symbol. Here input side there is a curve. This is the 2 input OR gate. So output become A plus B. If I give x and y, it will become x plus y. Okay. So AND gate, if I give AB, it will become A dot B or AB, A space B, like that. So this AND gate can show like this also. It is looking like a buffer, but here buffer has only one input, but AND gate has 2 inputs. And one more thing you can observe, even it is matching to OR gate, but in the OR gate input to this is curve, but here for AND gate it is always straight. So when you compare with buffer, you have to look into number of inputs. When you compare with OR gate symbol, you have to look into the shape, starting shape. Okay, right. So out of this NOT, buffer, OR, AND gates, these all 4 gates contain only one output, but when coming to input, NOT and buffer contain only one input, but OR and AND gates may contain minimum 2 inputs and maximum any number of inputs. We can say n inputs. Okay. So there are some special gates like they contain multiple outputs also. But here we are discussing the gates with contain only one output. Okay. So why the meaning of AND and OR? Suppose NOT means I said when we give 0, no 1, like that. What is the meaning of AND? It means if you observe, we are getting output of AND gate 1. when A and B, this and this, that is the meaning. Suppose Y or, so either A or B, like that. If anyone is 1, either A or B, then output become 1. That is the meaning. Okay. So this is about basic gates, basic logic gates, digital gates. Okay.